Hello guys, today we are going to solve the Geeks for Geeks problem of today, that is of 30th May. So the problem is word search. So the question is clear that we are given a two-dimensional board of letters and a word, right? So we need to check if the word is existing in this board or not. So we can, at a time, we can only move horizontal or vertical, means up and down or left and right. Same letter cannot be used more than once. Okay, so once we take a letter we can either move to only the three sides of that, so we can't take that letter again. Okay, so basically I had seen many solutions of the peoples, like they are solving, some are solving using Backtrack, some are solving using DFS, BFS. So what's the basic idea why you can't able to figure out like which solution you have used? Actually, I had seen many solutions where the people are using BFS, but they are mentioning that they are using DFS. So the thing is that we need to figure out, we need the ability to figure out this concept. So I will be explaining you with all these concepts, like how you can figure out which solution is solved using BFS, DFS, and what is the concept of backtrack, and how you can figure out whether the solution is solved using backtrack or not. So basically the thing is that the solution can be solved using all of these three methods, right? First of the thing is that you can use either BFS, DFS, or backtrack to solve this solution. Okay, so for example, if you see, here is the board A, G, B, C, Q, E, E, L, G, B, K, S. You can see geeks, and here you can figure out the geeks. So it is present in the board, since we'll return the true. That is one. And since this letter is not present, we will return the false. You can see the time complexity. Time complexity is of exponential time, which is similar to backtrack, and you can also solve this problem using DFS and BFS, that I will show you now in my solution how you can figure out like I had used BFS or DFS. So first let me explain my solution. This is the solution which is following DFS and backtrack. So first of the thing is that backtrack and DFS are similar here, because backtrack means traversing through all solutions, right? And since in the question it was mentioned we can't travel more than once, so in backtrack we are updating the backtrack, traditional backtrack solution, with a visited array to avoid revisiting of same letters, right? So we are updating traditional backtrack with a visited array to avoid revisiting. Okay guys, so this is the basic concept. And since backtrack is also similar to the DFS, like we are traversing through one, from starting from one point going till the end of that other point, and if it satisfies the condition that we want, the condition here is what? Condition here is that it, the final word should be similar to the given word. So if it satisfies this condition, then we will return true, else we will again go back a stage, and we will again check, means we will, from back stage we will again go to the town, and we will again check the condition. So what we are doing is, instead of backtracking all these possibilities, we are just using DFS to track only those solutions which are similar matching, like we are not checking all these solutions. For example, if you see in this array, a q g is also a, if we use backtrack, then a q g is also a possibility which would arise. Now since a is not the first letter that would match g, so we will not use this possibility. That's the feature of DFS actually. That is the feature of DFS. We can use backtrack to solve this question. It will just take more time. That's it. Nothing else. So in backtrack, if we use, we will get A, Q, G as one of the solution which will return false. Another would come as A, G, E, Q, G. That would also return false. Similarly, this at the time it will come for geeks, and that would return true in the backtrack. But in DFS, what we are doing is we are just starting from those points which are similar to the first letter, and from then only we are doing backtrack. From that point only we are traversing through all the, like we are traversing from G to B, G to E, G2A, G2Q, like that. Okay, sorry, G2A only. The three parts are there, three ways. So this is the thing difference between backtrack and DFS is that in DFS we are only going through some cases of backtrack. That is the thing. Like DFS, you can say as subset of backtrack, because backtrack will consider all these possibilities, but DFS would consider only those possibilities which have matching letters of the first one, right? Now, since you got the idea of how to differentiate backtrack and DFS, whenever the solution is considering all the possibilities, you can immediately tell that it is a backtrack solution, else it might be a DFS or a BFS. Now we need to figure out why it is DFS and why it comes to be BFS, right? We need to figure out between those, DFS or BFS. So in my solution, if you see, I am using the two for loop for traversing through all the words, and I am checking the first word, right? So this makes my solution, either BFS or DFS, not backtrack, because I am starting from few of the solutions. So this makes it either BFS or DFS. Backtrack, it's not. So I am calling a function DFS, which will, after getting the first point, it will traverse through all the points, that is all the adjacent cells, and if it check if the letter is found, it will return true, else finally it will return a false. Okay, so this is the DFS function. As you know, is a safe function is also there, which will check if the cell lies outside the board or not. That is a safety condition. These are the moving possibilities for X, for Y. At a time, left, right, up and down. Four different directions are there. We are checking if the cell is visited once, we are returning false, right? We will not revisit those cells. As mentioned in the question, the same letter cannot be used. Else we will visit this if if the word if the size of the word is full, means we had visited that length of word without any error, right? We are always checking, so we will return a true, else we will traverse through all the possibilities. Like first A will be there, so means next cell we will move to next cell. We will check if the next cell is safe, and if the next cell is safe and we had not visited that cell yet. Okay, so after both these condition, we are also making a check. This would also remove the backtrack logic here. In backtrack you can't find these checks, because backtrack consider all these possibilities by default, but in DFS we are making a check at each stage. What is the check is whether the character is equal to the given character of the word or not. Like we started from G, but if we traverse to B, and since the character is not equal, we will not go to B. That is the DFS or BFS logic we are using here, but in backtrack you can't find this logic. So basically we are using, yeah, so we are checking if the DFS is there or not, and it will return true. If it will, again we are calling a recursion function to check till the end, and if at the end the word size will be same, means we had find our word, then we will return true, right? Else we will return the false. Now this is actually the DFS. DFS basically have the logic of, in DFS if you try to figure out going till the depth once to search this solution, right? This is the DFS. What the difference between DFS and BFS is that going uniformly, we can say. Uniformly means we are taking all the side elements and then we are moving one step ahead at a time. Okay, we are not moving to the depth. Like if we apply DFS on this, we will start from G, then we will move to E, then K, then S directly. But if we apply BFS here, then we will go to G. Suppose if we have an E here, then we will take this G, this E, and this E, both E. Means at a time we will take two elements with us together. So what? How can you identify whether we are using BFS here or not? So for that, I had mentioned one example. If you comment out these lines like this, now you can see the code is modified. We are initializing an answer as false. And for each of the tracks, we are updating the answer by its or. Like whether it, whenever it will get true, we will get the answer as true and we will finally return the answer. So the difficult difference between this and this one is this one actually returns the true value very soon, and this one takes a lot of time. Time complexity for this one is high, and time complexity for this one, this line, is low, because it will return true as soon as it will get the value true, but it will not return true as soon as it will get the value true, because it will collect that true and it will also check for false as well. So that is the condition basically we can tell as BFS, because we are traversing through all these possibilities. And in DFS we are just returning the true. So since the solution is on submitting, I can, let's see if the solution is fine or not. So yeah, it's perfectly working. I hope you got the idea of this BFS, DFS and backtrack solution in the video. So keep following us for more such videos. Like, share, subscribe the channel, and also keep join us to our Discord group where we will help you with more such questions and the knowledge about the technology. Let's bring it together. Thank you. Have a nice day. Bye.